smaller planet, bigger consequences. Imagine waking up one morning to find nothing has changed, except everything. The sky still shines, the continents still exist, cities still stand, but the world beneath your feet has shrunk. Earth is now the size of the moon. Its diameter, once a mighty 12,742 kilometers, is reduced to just 3,004, fall 1/4 the size. But the implications, they echo through every layer of nature, science, and survival. Because Earth's size is not just about space. It's about mass. It's about gravity. It's about whether a planet can even be a planet. Let's start with gravity. Earth's gravity is what keeps our feet on the ground, the atmosphere in place, the oceans from drifting into space. But if Earth were as small as the moon, gravity would weaken a lot. You'd weigh just 1/6 what you do now. Walking would feel like bouncing. A single jump could launch you meters into the air. Athletes would leap like superheroes. But with less gravity, your muscles would weaken over time, bones would lose density, and the human body designed for Earth's pull would begin to suffer. But your health would be the least of your worries, because gravity holds more than people. It holds atmospheres. A moon-sized Earth couldn't hang on to its current atmosphere. With such low gravity, molecules, especially light gases like hydrogen and helium, would simply drift off into space. Over time, even heavier gases like oxygen and nitrogen would escape. Winds would vanish. Clouds would stop forming. Weather as we know it, gone. Without the protection of our atmosphere, ultraviolet radiation from the sun would blast the surface. Cosmic rays would stream in unfiltered. And that's just above ground. Now picture the oceans. Earth's oceans exist because gravity is strong enough to hold water on the surface. But on a moon-sized planet, most of that water would boil off or escape into space over millennia. Seas would shrink to shallow basins or disappear entirely. Rivers would dry. Rain would cease. The hydrological cycle, the beating heart of Earth's climate, would break. What about life? Not just human life. All life. Photosynthesis needs atmospheric pressure and liquid water. Animal life needs oxygen. With little air and less water, ecosystems would collapse. Forests would turn to dry wastelands. Deserts would spread. Most species would vanish. Even extremophiles, the toughest microorganisms, would struggle under cosmic radiation and barren conditions. And if you thought technology could save us, think again. With no atmosphere to shield from meteors, even small space rocks would strike the ground with devastating force. Satellites would be harder to maintain in orbit due to weaker gravity. Rockets would need less energy to leave the planet, yes, but also less energy to crash into it. The moon-sized Earth would become a cosmic punching bag. Now let's look at the long-term effects. A smaller Earth would cool faster. Our molten core would solidify quicker, weakening or extinguishing the magnetic field that shields us from solar winds. Without it, the last scraps of our atmosphere would be stripped away. What's left? A dry, airless rock floating silently in space. Sound familiar? It should. That's exactly what the moon is. But let's say by some miracle, humanity adapts. We build sealed habitats, oxygen domes, underground cities. We harness geothermal energy, farm in pressurized greenhouses, and shield ourselves from radiation with thick layers of rock. A new civilization might rise, resilient, confined, and alien compared to what we know. But it wouldn't be Earth anymore. It would be a survival station on a glorified asteroid. So what if Earth were the size of the moon? We wouldn't just lose size. We'd lose gravity, atmosphere, oceans, and life. The Earth we know, a cradle of complexity and beauty, would become a shadow of itself. Not quite a moon, not quite a planet, just a remnant of what was. A whisper of a world, orbiting a star, longing to be whole again.